Light from the most distant stars travels through an absolute, freezing vacuum for millions of years before it ever reaches our eyes. Across that distance, the universe is mostly cold and silent. For over half a century, the moon has remained silent too. The footprints, rovers, and equipment left behind by the final Apollo explorers have sat undisturbed in the lunar dust since 1972. But the focus of space exploration has changed. The era of the short-term visit is being replaced by a commitment to permanence, a shift from merely reaching a destination to building the infrastructure required to stay there. The 2028 Artemis 4 mission is the definitive turning point in this plan. It is designed to execute 3 specific mechanical steps that will establish humanity's first permanent residence outside of Earth. Breaking Earth's gravity with the heavy components of a space station requires the SLS Block 1B. This upgraded version of the rocket uses a more powerful upper stage to deliver over 84,000 pounds of payload toward the moon. The Orion capsule serves as the orbital tugboat. It grapples the International Habitation Module, or IHAB, and ferries it to the station. Orion maneuvers the IHAB into a precise alignment. Once locked into place, the gateway's habitable volume nearly doubles, providing life support for long-duration stays. This orbital port is a mandatory prerequisite for the mission. It ensures that any crew descending to the surface has a fully stocked, pressurized command center waiting for them in the sky above. While the crew expands the station, another critical piece of hardware will already be in position. A commercial human landing system, launched ahead of the crew, waits silently in a high lunar orbit. The Orion capsule matches speed and orientation with this lander, docking at thousands of miles per hour to create a single integrated vessel. Once pressurized, 2 astronauts physically transition from Orion into the landing module, preparing for the final drop toward the surface. Mastering this mid-space transfer is the engineering bridge for the entire program. It allows NASA to separate the long-haul transit ship from the specialized landing craft, making the logistics of the descent mechanically possible. The lander detaches from the orbital station and begins its long, quiet descent toward the hostile terrain of the lunar South Pole. The terrain here is a heavily cratered landscape, far more rugged than the smooth plains explored by the Apollo missions. This region is defined by geographical extremes. Towering ridges stay in sunlight for nearly 90% of the year, while the floors of nearby craters have sat in total darkness for billions of years. Over the course of a week, astronauts will anchor a permanent base. They'll install foundational power systems and critical communication arrays to support teams living here long term. The primary goal is harvesting the ice hidden in those dark craters to provide oxygen for breathing and hydrogen for rocket fuel. This allows a permanent base to sustain itself without a constant, expensive resupply from Earth. From the isolated vantage point of the South Pole, Earth is a fragile sphere against the total blackness. It is a reminder of how far the species has traveled from its only biological home. Artemis 4 isn't the finish line, it is the proving ground. This mission is where we learn how to keep complex machinery and human bodies functioning in deep space for the long term. The lessons learned in the lunar dust, like mining water for fuel, are the exact capabilities required for the journey to Mars. The moon is the training camp for the rest of the solar system. We are a species that evolved on a protective, temperate world, now attempting to survive in a vacuum that is naturally hostile to life. The effort to build these ships and sustain life in the void is how we find our place in the silence. By establishing this first base, we ensure that when we look out into the dark, we are no longer just observers. We are building the infrastructure that carries us further.